Hey, what's up everyone and welcome to Daily Code Buffer. In this tutorial, we are going to see a complete Spring Data JPA in detail. Now, if you've already gone through the Spring Boot tutorial, then it's probably like you need to understand in depth about the Spring Data JPA. Now, in that particular tutorial, we covered the brief about the Spring Data JPA and we created few of the APIs. In this tutorial, we are going to deep dive about all the topics available in Spring Data JPA. Now, what we are going to cover in this particular tutorial? We are going to cover how to map a particular class to a particular database table, how a relationship is been created using the particular one-to-one mapping, one-to-many mapping, many-to-one mapping, and many-to-many mappings. So we'll go through all the different types of mapping relationships available in JPA. We'll also understand what is JPA and why we need JPA. And we are also going to see a different annotations available that will help us to create more robust applications, like how we can add the native queries, how we can add the GPQL queries, how we can add the embedded classes in our entities. All those different things we are going to see over here. We are also going to see how we can create the unidirectional and bidirectional relationships. We are also going to see how we can add different constraints and how we can match our entity with the exact table that we have in our database. So there is a lot of things that we have to cover in this particular tutorial. So I suggest you to do practice while I'm going through the tutorial. So you will get more understanding about the different topics that we are going to cover in this particular video. So grab a cup of coffee and let's get started. Now, when we are working with the Java applications and we have to connect to the database, what we do is we use JDBC. So JDBC is an API provided by Java, so we can connect with the database. Now, the problem here is Java works on the concepts of objects and classes, and database works in the concepts of tables that will be having rows and columns. Now, how to match together? Now, in the traditional way, if you're using the JDBC, what we'll be doing is we will be getting the data from the database that will be in the table. We are getting all the records and we are converting them in the objects or the classes that we have. So that's the conversion that we are doing. But ideally, we should not be doing those conversions. There has to be a system where it defines that this particular class or objects represents this particular table in the database. Now, for these reasons, there are different frameworks available that gives us the functionality that is called ORM, that is Object Relationship Mapping. Now, what ORM is? ORM defines whatever the classes or objects is defined in your system, in your Java application, that will represent the table in your database. Now, the frameworks like Hibernate, iBatis provides this type of functionalities. Now, what happens is Hibernate has its own implementation of ORM, how the different functionalities, how the different sessions, objects, and how it is behaving and how it is interacting with the database is different compared to how it's in the iBatis, because iBatis will also have its own implementation. If there is any other framework, those particular frameworks will also have its own implementation. Now, when this type of different implementations are there, when we have to change any of the implementation framework, like if I want to change from Hibernate to iBatis, then it's very difficult. So whatever the specification is being used by Hibernate doesn't necessarily to be used the same in the iBatis. So what the Java people thought of, let's create the standard specification, and those standard specification will be used by all the third-party API providers or ORM providers, and whenever we have to switch between those providers, it's very easy for the application developers. So suppose Java provides a JPA specification, that's a Java persistent API specification provided by Java, and all the framework providers like Hibernate, iBatis, and all the different available will be using those specifications and creating their implementation of ORM. So what happens is, if you are using the JPA and if you want to convert from Hibernate to iBatis or from iBatis to Hibernate, then you can convert it very easily. Now, the one important thing is what Java provides is just a specification. So you have to go ahead with the implementation provider. So you cannot tell that, okay, I'm just going with the JPA. If you're going with the JPA, you must be using Hibernate or iBatis or any of the framework, the ORM provider, because JPA is just a specification and you are using that specification via any of the framework provider or any of the third party provider ORM providers. So this way JPA specification is been implemented and the application developers implement those JPA using any of the third-party framework availables, and switching between them is very easy. So this is all about why JPA was introduced and how Hibernate and all those different framework uses JPA and how we can change whenever we need to change in our application. So now let's see what we are going to build it today. We are going to build a small relationship over here. I'll show you the example. You can see that this is the class diagram that I have prepared, and we are going to build this particular class diagram over here using the Spring Data JPA. Now, what all the things are over here? You can see that there is a student class, there is a guardian class, course, teacher, and course material over here. Now, all these different classes are represented by the tables in the database. So we are going to create the tables based on the classes that we have defined over here. Now here you can see that all these particular different classes defines a particular relationship with each other. So we are going to see what those particular relationships are and how we can define the relationship in the entity so that a particular represented tables are created in the database, and how we can store those data. So here you can see that we have a student class and we have few of the attributes available like student ID, first name, last name, email ID. This particular class have its name and have its different properties available. So that particular class, how it's represented in the database is that particular class name will be represented by the table name. Okay, and all the properties that are there like student ID, first name, last name, email ID, all those particular attributes are represented by the different columns. So there will be different columns, and for all the columns we will be inserting the records over there. All those particular records will be rows created, right? So this is just a simple representation how an object will be represented in a database table. Now this particular student will have a guardian. Who is the guardian for that particular student? So that relationship how we want to define, we will be defining in our system. Now there is a one-to-many relationship between student and courses, because one student can opt for many courses available. Now there is a one-to-one relationship between course and course material. For every course there will be a one course material object, and without the course you cannot create the course material as well. So there is a one-to-one relationship between course material and course available. Now between teacher and courses there is a one-to-many or many-to-one relationship, you can say, because one teacher can teach multiple courses, and on the other hand you can say that multiple courses can be taught by one of the teacher. Okay, so there will be one-to-many relationship or many-to-one relationship. How you can define in the system, that will represent what you are going with, many-to-one or one-to-many. Now between student and courses, multiple student can opt for multiple courses. So it's a many-to-many relationship. Like many students will be opting for many courses. So this is just the overview of all the different classes that we are going to create and how they are related with each other. So when we create the application, we will be creating all these particular classes and we will define the relationships as well. Now let's go ahead and create one Spring Boot application where we will define the Spring Data JPA and we will connect to our database. So let's go to the Spring initializer over here. Okay, start.spring.io, and let's define the properties over here. I'll define group as com.daily code buffer, artifact as Spring Data JPA tutorial, name as Spring Data JPA tutorial, and package name I'll define as spring.data.jpa tutorial. Okay, so this is just a simple package name that I have defined over here. I'll be using the packaging as jar file, Java version as 11, and let's add the dependencies. As we are going with JPA, first thing we'll add is Spring Data JPA. I'll add the Lombok dependency, okay, to reduce our boilerplate code, and I'm going to use the MySQL database, so I'm going to add the MySQL driver, and let's add the Spring Web dependency as well. So suppose if you want to create the REST APIs out of it, you can create the REST APIs as well. Okay, so these are the 4 dependencies I have added over here. So let's generate the project and open in our IDE. So I'll be using IntelliJ IDEA. You can use any IDE of your preference. Okay, let me open IntelliJ IDEA. Open project and Spring Data JPA tutorial. So it's resolving the dependencies. Let's wait for a second. Okay, so this is my project over here. Let's open the pom.xml file, and here you can see that we added Spring Data JPA, Spring Starter Web, and if you go to Spring Starter Data JPA, so this particular Spring Data JPA is using Hibernate as its default implementation over here. Okay, so we are using JPA with the Hibernate implementation. Okay, if you want to change it, we can change it as well. Okay, let's go with the default for now. Okay, so this is our pom.xml file. All the details are there. Now what we have to do over here, let's open the MySQL as well. Okay, I'm using MySQL Workbench 8.0 CE. So this is our database now. Here you can see that we have only default databases available. So what we will be doing is we will be creating one of the database over here, and we will be providing all this particular configuration details in our Spring Boot application so that Spring Boot application can connect to this particular database. So let me go ahead and create the database over here. I'll just go ahead and create schema. I'll say SchoolDB over here. Apply the changes, finish, and here you can see that SchoolDB is created and there is nothing inside this particular schema. Okay. Now what we have to do is, for our Spring Boot application to connect to this particular database, we have to give the properties in our application.properties file. So let's go to the src main resources application.properties, and here we can define the configuration. Okay, so let's add those configurations. Now here you can see that I have just copy pasted the configurations over here, and this is very simple. Here you can see that I have just added spring.datasource.url, the URL of your database, the username and password of your database, okay, and which particular driver that you are using. As we have added MySQL driver and I'm using MySQL database, I have just defined that I'm using com.mysql.jdbc.driver over here, and I just defined spring.jpa.showSQL as true. So whenever we are doing any operation, all those particular queries will be printed in the logs. Now this particular thing, spring.jpa.hibernate.ddl auto, this particular thing I have defined as update. Now this particular thing defines whatever changes that you do in your application, like whatever entities and whatever classes that you define, those particular thing, how it will interact with the database, that has been defined by this DDL auto. So suppose currently if you see that I have added update, so whatever the updates I do in my entities or any of the objects that I'm creating, those updates will be applied to my database directly. So suppose what will happen is, if you have 3 fields available in your database and 3 particular available in your classes as well, and if you add 2 new, that 2 new changes will be applied to your database as well. So there are different properties available for this. Okay, you can go and check that out as well. It is advisable not to use this particular property in the production application, because generally when you are working with the production applications, there will be a different team available that will be handling your database operations, and different scripts you need to create to do all the changes regarding your database, and your application will be different. So this particular thing that I have added over here, just to make sure that whatever changes that we are doing in our application, that is directly been reflected, and you can directly see what's happening in the database when we do any changes in our entities over here. So for that purpose only I have added over here, but whenever you're going with the production, you should not use this. It's not advisable. And whatever particular database objects or database tables are there, how to create the same representative in the class that we are going to see over here. So suppose any new constraint is been added in your database, how to add that particular constraint in your entity in Java, that we are going to see over here. So you can match all those particular things. So this is a simple configuration that has been added over here. Now let's move ahead and let's create the entities over here. Let's see how to map a class to the table. So with this particular example that you can see over here, okay, these are the different classes that we are going to create and how to map that. So let's start with the student over here. We'll create the student class and let's see how we can map that particular class to the database. So we have student class which is containing student ID, first name, last name, email ID, and the guardian details as well. So let's go ahead and create that. So I'll go to IntelliJ IDEA in the Java folder. Let me create one package over here. I'll say as entity. Inside this particular entity, let's create the class, and I will call this particular class as student. This is the class. Now to represent this particular class to a database, to make our system know that this is particular entity that you're going to create to map to the database, we have to annotate this class with @entity. And you can see that we are using javax.persistent.entity package over here. Now whatever we do in this particular student class, that will be reflected in our database. Okay. Now what we want in this particular student class, here you can see that we want student ID, first name, last name, email ID, and the guardian details. So let's go ahead and add that. So I'll say private long student ID. Okay, private string, first name, private string, last name, private string, email ID, and we need to add the guardian details as well, right? So let's add those as well. Private string, guardian name, email and mobile number. Okay, private string, guardian email, and private string, guardian mobile. Okay, so these are the different fields that I have added over here. Now we need to have the getter setters and the constructors and toString method over here. So let's use the lumbuck over here. So I'll just define @data using the lumbuck. So all the getter setters and toString and hash code and equal methods will be generated over here. And I need all args constructor over here, and I also need no args constructor over here. Okay, one more thing I'm adding over here is @builder to add the builder pattern for my entity class over here. Okay, so this is just a simple thing that I have created over here. Now this student is a particular class that represents the table using this entity. Now whatever the table that we are going to create will always have one primary key to define the unique identifier for all our records. Okay, so how we can create that? So this particular student ID I want to create as a primary key. So I'll define with @ID over here of javax.persistent. So this particular annotation @ID will define that this particular field is the primary key over here. Now let's run this application and let's see what is happening. Okay, there's a lot of changes that we are going to do, but let's see what is happening till now. Okay, if you go to the database, okay, there is nothing available over here. Okay, I'll go to the main class file over here and I'll just run this application. And here you can see that create table student. Okay, here you can see that whatever we have defined in this particular student class, okay, that particular update operation happened to our database because student table was not available. So, and in our application we have defined the student entity, so that update happened to our database. So this new table is created. And if you go ahead and check in our database, here you can see that this particular tables, we are getting one student table over here. And if you see over here, these are the columns available: student ID, email ID, first name, guardian mobile name, and last name. Okay, here you can see that whatever you defined student over here, okay, in the lowercase, it created the same table name over here. And whatever the camel casing that you have defined over here, and here you can see that using the underscore as a separator, all those particular columns are defined over here. So that's a default format available when you are creating the entities and how those particular entities will be created in the table format. Now this particular table is created, right? Now, as I already told you that when you're working with the production application, you won't be using this particular functionality like DDL auto update. There will be already table created and you need to define that particular table in your entities. Now, suppose the name of that particular table is TBL underscore student. How you will define that in your entity? Like this particular student entity is representing that TBL underscore student in my database, because currently if you see that whatever is defined student, the same student table is created. Okay, the column also similar way. So let's see how we can define all those particular things. Now one more thing to note over here is, as I already told you that we are using DDL auto as update. So whatever the update operations we are doing, those particular changes will be happening, and sometimes it may not change the table structure as well. So what we will be doing is, sometimes we will be deleting the table and we will be starting our application so that fresh changes will be applied, so we can see what is actually happening over here. Okay, so let's go back. Let's stop the server and now let's add few of the details. Now what I want to do is, I want to add this particular student entity into my database as a TBL student. I want to represent with underscore TBL underscore student. Okay, so I'll define this using @table annotation. Okay, and inside this table annotation, what is the name of the table? So I'll define as TBL underscore student. Now if I start this particular application, what will happen is new table will be created with the name TBL underscore student, because whatever changes are already there in the database, it will remain the same and the new updates will be added. This particular Hibernate will understand that okay, TBL underscore student is a new table that is not present in the database. So let's create it. So it will go ahead and create it. So that's why I was telling that whenever this type of things will happen, we will delete that particular table and we will start our application to apply all our changes freshly. So this is the way that we have defined the name of the table. Now how to define the columns as well. So suppose let's go ahead and I want this particular email ID as email address, not the email underscore ID. So to define that, we can use @column annotation to define the name of the column. So here I'll define that name of the column is email underscore address. So this defines that whatever the email ID is represented over here, and in the table it will be represented by email underscore address. So this way you can see that we have added the configuration for how our table should be and how our column should be. Ideally, you should define all these particular annotations and all these particular values for each and every field. So here, due to the time constraint, we won't be adding for all the particular fields. Okay, so this is how you can add those particular annotations. Now, whenever you're working with the primary keys, you will be incrementing those particular primary keys and you are going to store those particular values. So in the ideal scenarios, you will be using the sequence generator, using the sequence. Okay, so that particular sequence will be auto generated, auto incremented every time when you're going to store the particular data. So let's see how we can add those particular things. So in this particular student ID, we will be adding the sequence generator, how the sequence should be generated, and in the generated values, how we have to use those particular values. So let's see the annotation @sequence generator over here, and here we will define what is the name of this particular sequence generator and what is the name of the sequence as well. So if you're familiar with the databases, you will be having the sequences created and those particular sequence will be incremented when you want to store those particular values. And here I'll define the allocation size as well. Okay, allocation size is 1 and the name of the sequence is student underscore sequence. Define the same over here, that name of the sequence is student underscore sequence. Now we will define how to generate those particular values for the student ID. So we'll use the generated value annotation. Okay, and here we will define what is the strategy. And here we'll define strategy should be generation type dot sequence, because we are using the sequence to generate the values. And we'll define the generator, that means our sequence. So this is a simple annotation that we have added. What is the sequence generator, and in the generated value annotation, what particular strategy that you want to use. If you're using auto, if you can use identity as well, but we want a particular thing. We have a particular requirement that we want to use sequence. That's how ideally you should be doing in the production application as well. So we have defined that way, that generation type is sequence, and what sequence that I want to use, that whatever I have defined over here. Now based on the drivers that we have used, this particular sequences will be created. Now if you're using the Oracle, the sequence will be created. In the Postgres also the sequence will be created, but in the MySQL sequences are not there. So it will create one of the tables over here and it will increment the values every time when we are doing the insert operations. Now in our table, sometimes we will be having our different constraints as well. So let's define the different constraints. Suppose if you see my email ID over here, okay, this email ID, whatever I defined, should be unique for every student. Okay, like multiple students cannot have the same email ID. So I want to define a constraint for my table that this particular column should have a unique value. So let's add that particular constraint. So to add that particular constraint, we will go over here in the table annotation, whatever we have defined the name. Here you have unique constraints available. Okay, so let's use this and we will do @unique constraints, and let's define the unique constraints over here. You can add multiple unique constraints over here, so that's why it's a list over here. And here you can see that you can define the name of the unique constraint and the column name as well. I'll define this as email ID underscore unique and column name as email address. Okay, simple over here, right? Now as we are adding this particular email ID as unique, I want that particular email ID from student every time, right? So whenever we are adding the new student in the database, I want that particular email ID, because as we have added the unique constraint over here, that means that particular email ID will define that particular student. So in the columns, we can define the nullable columns and non-nullable columns as well. So this particular email ID should be non-nullable column. That means we should be getting that particular value, right? So let's define that. So in this particular column annotation for the email ID, we will define that this particular nullable should be false. That means every time we should be getting this particular value. If you are not getting this value, it will throw an exception over here. So yeah, you can see that we added a lot of things in our entities over here, right? We define the table information, unique constraint, the sequences, how the sequences should be created, how the value should be incremented, and how a column should be defined. It's a nullable column or a non-nullable column. All those things we have defined. These are the general things that will be available for your tables. Okay, so whatever is there, you can define this way over here. Now I will show you what will happen over here when we run the application. Currently you can see that we already have one student table over here, and when we start our application, as we have defined the DDL auto as update, a new table will be created. Okay, I'll show you that in a second. Here you can see that create table TBL student, whatever we defined over here. Okay, so that means a new table is created. So in our database, there is two tables, student and TBL student. So yeah, what all things happen, you can see that it created the table over here with all these particular fields. Here you can see that it altered the table and added the constraint over here, unique constraint that we have defined. Okay, and you can see that it also created the student sequence table over here, and it added the value 1. So whenever we are adding the values now in the database, that particular one will be used to insert the data, and that particular value will be incremented then. So let's go to the database and let's see what happened. SchoolDB, I'll just refresh it, and here you can see that there are two tables created. Student was already there, TBL student was created. Okay, these are the columns, and if you go to the indexes, there is a primary key that we have defined, and there is also a unique key that we have defined over here. Okay, but I don't want this particular two tables over here. So what you can do is just delete those particular tables and restart your application, so that particular only one table will be created. Now let's understand repositories. So let's go to the application. Let me stop the server. Now as a repositories, there are different types of interfaces available that defines the different implementation of different methods that we can use directly for our entities that we have created. Suppose if you want to save that particular entity, if you want to delete that entity, if you want to get all the records available for all those different standard operations, there are different default implementations added using the different repositories in the Spring Data JPA. So let's check what all the different things are available. So what I'll do is I'll create the student repository and I'll implement the different repositories. I'll show you how to extend the different repositories available for our student entity over here. So let me go ahead and create one package over here, and I'll say as repository. Okay, and for this particular repository, I'll create one interface, and I'll say this is a student repository. Okay, now I'll define this @repository. Over here, it's a stereotype annotation, so Spring will understand that this particular interface that we have created is a repository interface. Now, this particular interface can extend different repositories available. So if you see JPA repository, okay, this is the repository available, and this particular repository, if I open this, now you can see that this particular JPA repository is the interface that extends paging and sorting, repository and query by example, executor over here. And this particular JPA repository is using the generics, which is taking T and ID. T is your entity over here and ID is the type of the entity that you have defined. So in our case, T is student and ID is of type long that we have defined over here. Okay. Now here you can see that there are different methods available, like find all. Like find all will return the list of T available. So T is student, so it will return the list of students available. Find all method is there. This find all is taking sort as the input parameter, so we can define the different sortings over here. It can save all the data, it can flush, it can save and flush. All these particular different methods are available in JPA repository. Now if you see, JPA repository is extending paging and sorting repository. So let's see what different methods available there. You can see find all and find all using the page. So if you want to implement paging to get the different records available using the pagination type, we can do that as well over here. And this particular paging and sorting repository is again extending CRUD repository. So this CRUD repository is having the different methods such as save method, save all, find by ID. So this will defaultly get you the data based on the primary key that you have defined. You can see it's passing the primary key over here. Okay. So it is also have the method like exist by ID if the value record is available or not, find all by ID, count how many records are there, delete by ID, delete. So you can see that these are the default implementations available for our repository. So we can directly use these particular methods to reduce our efforts over here. And there are a lot of different functionalities extra available that you can use to create the different implementation, custom implementation as well. So we are going to see all those particular things in the later part of the video. So you can see these are the methods available. Let's close these things. Okay. Let's define the JPA repository for now over here, and we'll define that it's of type student and of type long over here. Simple thing. Now let's test whatever we have created over here. Okay. So ideally you will be creating the REST APIs and you will be calling those particular repository methods from the REST API. Here what we'll be doing is we won't be creating the REST APIs. We'll be just creating the test class to test this particular repository that we have created to save the time over here. Okay. And if you want to understand how to create the REST APIs and how to interact using this particular repositories, I have created a dedicated video, Spring Boot tutorial, the advanced course. You can go ahead and check that out as well. In this particular video, our main focus is to how JPA works. So we'll be only focusing on the repository layers. Okay. What we'll be doing is we'll be creating the test class for this, and we will create the different test methods, and we will call the different methods available for the student repository and call them. With alt insert, you can go for the generate and you can generate the test class. So I'll just define the simple test class over here, that is student repository test over here, and I will annotate with Spring Boot test over here. Now ideally you should not be testing your repository layer using the Spring Boot test. There is a different annotation available, that is @data JPA test. What this particular thing will do is it will help you to test your repository layer, and once the operation is completed, it will flush the data. So the database won't be impacted. But currently we want to impact our database. We want to store our values into our database so we can see what's happening over here. So that's why I'm going with the standard testing over here. Now for this student repository test, we need a student repository. So let's go ahead and create the object for it. Student repository, and I will auto wire it. Okay. Now let's create one method to save the student over here. So what we will do is we'll create the method public void save student. Okay. And I'll annotate this particular method with @test. So we can run this particular test case. So don't focus on the test cases that we are creating. Just focus on what's happening when we are using the repository, how Spring Data JPA works, and how we are going to store the data, how we are going to fetch the data. All those particular things are more important in this particular course. Okay. So to save the student, we need to create the student object with all the values that we have. In the student class, you can see that we have used the builder pattern. So we are going to use this builder pattern to create our object. So what we'll do, I'll just say student equals to student dot builder dot, we are not going to store the student ID because student ID will be auto generated using the sequence that we have provided. Let's pass the email ID. I'll say shabir@gmail.com. I'll say first name as Shabir dot last name as Daudi, and let's add my guardian name as well. I'll just say any name, Nikhil. Guardian email as nikhil@gmail.com. Guardian mobile 2 3 4 5 6 7 8 9 10. Anything remaining, guardian email, guardian name, last name, first name, email ID, guardian mobile. Okay, and build. So this particular object is built. Now what I want to do is I want to do student repository dot save. What I want to save? This student object. Simple. Okay, so I'm just using the save method of a JPA repository. JPA repository is again extending the CRUD repository. So you can see that this particular save method is part of the CRUD repository over here. Currently, if you go and check the database, this particular student repository is going to use the tbl_student over here. Currently, you can see there is no records available. So let's go ahead and run this particular method. Okay, you can see that this particular method is successful. Now if you go down over here, you can see that these are the particular different queries that are being executed. You can see that select next val as ID val from the student sequence. Okay, so it took the value from the student sequence that we have created, and after that it updated the sequence to the new value. Okay, and it inserted the data into TBL student over here. Okay, so these are the three queries that has been executed over here, and if you go ahead and check the values over here, you can see that we got the values. Student ID as 1, email ID, first name, guardian email, guardian mobile, guardian name, and last name. All the particular data has been saved over here. It's cool, right? With one method, with one line of code, you are able to save the data over here. Now let's create one more method to get the list of students available in the database. So let me just create one more method. Public void print all student. Okay, and this is also I'm going to annotate with test over here. And what I'll do is I'll just define list of student list, and this is from java.util equals to student repository dot find all. Simple over here. Okay, and let me just print it. Okay, let's run this particular method as well. Now as we have only one student available, that particular student will be printed over here. Yeah, you can see that the query was executed. Select all the particular columns from that particular tbl_student over here. Okay, and this is the data. Student list equals to first student, that is student ID, first name, last name, and all those particular details available. Cool. So everything is working fine. Now in this particular student class that we have created, there is an improvement that we can do. So let's see what we can do over here. Now if you see over here, this particular student class contains this particular fields over here, that is guardian name, guardian email, and guardian mobile. Ideally this all details should be in this separate class, because student is a separate class, is a separate object, and guardian should be a separate object, and there has to be relationship between these two. There has to be different relationship available, but ideally this particular data should be saved in a single table in my database. Okay, so let's see how we can do that. So this particular property is available. Guardian name, guardian email, guardian mobile should be in the different class itself. So let's go ahead and create the guardian class. Okay, and this particular guardian class will be having those properties. I'm just removing from here and I'm adding those properties over here. But this particular guardian class cannot be an entity because I don't want to have the different table for it. I want to use this particular properties for my student table only. So how we can do that? We can do using the embed. Okay, we can embed this particular class inside my student. So for my student class to embed this guardian class, this particular guardian class should be embeddable. So I'll define this as embeddable. Simple, right? So this particular class is embeddable. Now I can use this particular class in my student. So let's go back to student, and here I can define private guardian, and this is embedded. Now this particular guardian class should also be annotated with @data because we need data setters, we need all args constructor, we need no args constructor as well. Simple over here, right? Now as all these particular properties are inside this particular guardian class, can be directly named, right? Email and mobile number, which makes more sense. Okay, but now what happens once we do this? Because as we have the properties in our table, that is guardian email, guardian mobile, guardian name, and here we have defined as name, email and mobile over here, we need to map it together. Okay, so here what we have to do is we have to map this particular attribute to our database that we have, or to all these particular properties. So we need to use the attribute overrides annotation over here. So let's see how we can do this. So what I want to do, whatever the properties are there, this name, email and mobile number should represent to guardian email, guardian mobile and guardian name over here. So let's see how we can do. We can use attribute overrides annotation over here, as we want to override multiple attributes. I'll define the list over here, and here I'll define attribute override over here, and it have name of the attribute and the column name. So let's define those things, and column over here. So the name of the attribute is this one, this name, and here we need to define the column over here. Okay, and in this particular column, this is a column, so we need to define column over here, and this has the name of the column we need to define as guardian underscore name, whatever is over here, guardian underscore name. Okay, cool. Now the same thing we have to define for the rest as well, email and mobile. So let's go ahead and do that. We'll say attribute override, and I will say name equals to whatever the name is email, and column equals to column, and name of the column is guardian underscore email. Okay, one more attribute override, the name of the attribute is mobile. Okay, and column we have to define column equals to column, and inside this let's define the name equals to guardian underscore mobile. Hope the spellings are correct, name, mobile and email. So we just define the 3 attribute overrides, like this particular attribute should define to this particular column name, and this particular guardian we have added as a property in our student. So all good. Now there will be a issue how we define how we create the student object. So if you go to the student repository test over here, you can see that now there is no longer a guardian name available. Let me just comment it over here for now. So there is no issue for now, and let's create a new method, save student with guardian. Okay, public void save student with guardian details. I'll annotate with test over here, and let's define student equals to student dot builder dot build. Okay, so here I need to define dot first name as Shivam dot email ID as shivam@gmail.com, last name as Kumar dot guardian. Now this guardian will take the entire guardian object. Okay, so let's build that as well. So what I'll do, I'll just create the guardian object over here. Guardian equals to guardian dot. Okay, let me go to the guardian and let me define the builder pattern over here. Now you don't have to do this. Okay, I like builder pattern and I like the way it looks, so that's why I'm doing it. Okay, guardian builder dot build email. I'll use the same information. Okay, Nikhil is the guardian. Dot name as Nikhil dot mobile as 1 2 3 4 5 6 7 8 9. Okay, some number and build over here, and I'll use this guardian over here, and I need to save this object. So I'll just say student repository dot save student. Now let's run this. Yeah, you can see that it is successful, and here you can see that the select for the sequence, update for the sequence, and insert into table over here. And if I run the query again, you can see that we are getting the record Shivam and all these particular details. So here you can see that we separated out the two different classes over here. Okay, that is guardian and student, but we represented the same in our database over here using the embeddable and embedded over here. So if you have something like this when you are using the inheritance parent-child relationship, you can go ahead with this particular approach. Now let's see the different methods available, how we can create the different methods in our student repository. So suppose we saw that there are only few of the methods available in our student repository, but if you want to create the custom method, suppose I want to get the student's record based on the name of the student. So let's see how we can do that. So in the student repository, student interface, we can define the methods. So I'll just define public, and I'll say my return type is list of student. Okay, and the name of the method that you give over here, it has to be in the format that has been defined. So I can define find, and by what? By by capital, and then you need to define the attribute name. So if you go to the student class over here, and here you can see that it is first name over here. Okay, it is in the camel casing. Here also it should be in the camel casing. So I'll just define over here, and as it's in camel casing, F should be capital over here. Okay, find by first name, and then you need to pass the string over here that will be containing your first name. So I'll just say first name over here. That's it. You just need to give the definition. You don't have to implement it. So I just define one method that is find by first name. So let's go ahead and test it out. We'll go to the student repository test over here, and let's create one more method. We'll say public void print student by first name. I'll annotate together test. And I'll say I just need list of students equals to student repository dot find by first name that we have defined, and I want the records that is having first name as Shivam over here, and let's print it. Let's run this. So we should be only getting Shivam over here, and we'll see what query we are getting out of it. Okay, so here if we scroll down over here, you can see that we got the one record which is having first name as Shivam over here. Okay, only one record over here. Now if you see the query, here you can see that it is doing select from all the particular columns available, And at the last, if you go where student dot first name equals to whatever the value that you are passing over here. So this way you can see that you can create the methods. Now suppose you want to create the methods to fetch the student who's containing first name as some of the characters. Okay, so suppose currently you see that we have just defined that first name is exactly matching that you provide over here. But suppose if you want to get the particular students with some of the particular characters that you want to match, so that you can define using this way. I'll just say I just need list of student find by first name, and I'll say containing, and I'll pass string name. Okay, simple. So what I defined over here is I need the records based on the first name, but it has containing characters. Okay, I don't want to match the entire string particularly, but if we have some of the characters, I want that particular records. So let's go to the student repository test again. Let's copy paste this method. First name, I'll just say containing, and here also I'll just say find by first name containing, and I just need data which contains sh. So let's run this. So here you can see that the query executed. If you go at the last, okay, you can see that the first name like whatever you have defined. Okay, like it's doing the escape characters. Okay, percentage whatever the name that you are giving, and percentage over here. And here you can see that you got both the records, Shivam and Shabir, both the one. So this way you can create the different methods as well. Let's define one more method. Okay, we'll just say I just need a list of students. Okay, find by suppose last name. We just implemented the method to get the data by first name. Now find by last name, and that should be not null. Okay, simple. I want the records which are not null. Okay, so it will check that last name is not null. We will get those particular records. Now suppose you want to get the data based on the guardian name, so that also we can do. We can just say list of student find by. Now this you need to define based on the attributes. So in the student table there is an attribute called guardian. Okay, so you need to define that find by guardian. This G should be capital, right? And for which particular attribute in that guardian as well. In the guardian I need the data based on the name. So I'll just find name. Simple, right? And I'll just say string guardian name over here. Let's test it out, this method as well. Let's go to the test class and let's implement a method public void print student based on guardian name. I'll annotate with @test. Okay, and let's implement this. I just need list of students equals to student repository dot find by guardian name, and guardian name I'll define as Nikhil, and I'll print this out. Let's run this. You can see that how simple is this, right, to implement all these particular different methods. Here you can see that the query is select all the records, and at the last you can see that where student dot guardian name equals to this. Okay, so with this particular name that we are defining over here, JPA is able to understand what we are saying over here. Okay, and we got both the records, that is Shabir and Shivam, as both is having the same guardian over here. Now if you go to this particular documentation, if you go to the Spring Data JPA, learn and go to the reference documentation over here and go to the query methods And here you can see that there is a list available over here. Okay, how you can define your method name. Currently you saw that we defined few of the methods over here in the student repository. Okay, find by first name, find by first name containing, find by last name not null, find by guardian name. And here you can see that the list available how you can define your own method name as well. So if you want to get the distinct records, you can say find distinct by first name, last name, or whatever you want to give over here. And if you want to get the records based on the two values, suppose you want to get the data based on your first name and last name. So here you can see that and keyword you can use like find by last name and first name. So you can define this way like find by first name and last name. I want to get the records. And in the parameter, you can define that way. Suppose I want student, okay, find by first name and last name. Okay, and here I need to define two values over here, string first name and string last name over here. This y should be small over here. Okay, find by first name and last name. And here you can see that if you want to get the records by find by first name or last name, you can define that way as well if you want to match the particular values. And here you can see that how the sample should be, and here you can see that how the JPQL snippet is for that. So how a JPQL query will be represented for that particular thing. We will come to that part, how to add the JPQL queries, how to get the data based on JPQL queries as well. But if you come over here, you can see all the different examples over here, and based on this example, you can create your different method names. Okay. Here you can see that if you are using any values like find by start date between, find by age less than, all these things you can do over here. You can see that we use this particular one, right? Find by not null. We define find by last name not null. You can use the like operator, not like operator. Okay, starting with this, ending with this. We use this one containing, right? Containing any of the particular characters over here. You can use order by, last name not, last name in, not in this. It's true, false. If you have a boolean values, you can go with the find by true, find by false as well. And you can go with the ignore case as well. So you can see that if you define ignore case, both the places when you're matching, the values will be used as uppercase. So this way you can go through this particular article. I will add the link in the description below so you can check that out. These are all the different ways that you can create the method as well. Now the time comes when creating the method name is not enough. You have to create the different method name, and you have to specify the different query as well, right? Like based on this query, I want to get the data. So for those particular cases, you can use the @query annotation, and you can pass the JPQL queries as well. So let's see how we can do that. Let me go to the IntelliJ IDEA and let's create one method over here. What I need, I want student, and I'll just define get student by email address. Okay. Now this is and I'll define string email ID as well. Okay. I want this particular method. So here you can see that I've just given the different name over here, so you're not confused like with this particular default implementation methods over here. I just gave the get student by email address over here. Now here what I want is, as our email ID is uniquely identified, as we have added the unique identifier for this email ID, I want that particular student based on the email ID that I have provided. But I want that data based on the query. So I need to pass the query. I can give that query using the query annotation. And here I can pass the JPQL queries. Okay, if you go to this particular document, you can see that these are the JPQL queries snippets over here. Okay, select distinct and all those things. And if you come over here, what I can do, select, I can define select as from student as. So the JPQL queries are defined in a separate way rather than the native SQL queries. But this is a very simple over here. Okay, so the JPQL queries are defined based on the classes that you have defined, not based on the table names and the table attributes, table column names. This will be defined based on your class that you have created and the attributes that you are using in your class. So you can see that I'm not going with the tbl_student. I'm going with the select as from the student class that I have created, and I want the student where s dot whatever the attribute name. In here you can see that my attribute name is email id. Okay, so I'll define s dot email id equals to $1. That is the first parameter. So I'll just define here as this is the JPQL as well. So here you can see that we just defined a simple query over here, that is a JPQL query. JPQL queries are based on the classes that you have created, not based on the tables in the database. Okay, so that's the one thing that you have to take it in the mind. So student is the class that we have created, email id is the attribute property in my student class, not the email underscore address that has been defined over here. Okay, here is email underscore address, but we are using this particular thing over here, and this should be small email, right? Now let's create a test method to get the data. I'll use this name only, public void print get student by email address. Okay, and I'll annotate with @test over here. What I'll do, student equals to student repository dot get student by email address, and here I'll define the email address. I just say shabir@gmail.com. okay, and I'll print this student over here. Simple thing that I've defined over here. Okay, nothing complex. So let's run this. Here you can see that the query is executed. Select student, all the particular values, and at the end you can see that email address equals to whatever the email address was passed, and here you can see that only one record has been fetched over here. Now suppose if you want to have only one value, suppose let me copy this thing. Okay, and I'll just say get student, I'll just say first name. Okay, so I just need the first name by the email address that I'm providing over here. So here I'll define s dot first name, that I just need first name. I'll go to the student, I'll just copy this from here, and I just need s dot first name from the student as where s dot email id equals to parameter 1, that is email id that I'm providing over here. And I don't want as a student, this is the string over here, because I'm just getting the one value over here. So let's go ahead and test this as well. Public void print this. I annotate with @test. This is string, right? So I can directly use string first name equals to student repository dot get student first name by email address, and I'll just define this email address, that is shivam@gmail.com. okay, and I'll just print this. Very simple thing over here. Let me run this, and here you can see that the query was executed. Select only first name as the first column from this particular table where email id was, which whatever was provided over here, and only one particular value was printed. Okay, so you can mix and match this way, and whatever the way you want to define the particular queries and the way you want to get the data back, you can define in the particular method this way. Now you can see that we have defined a lot of methods over here, right, in this particular repository. Now let's take to the another level. Now you have a very complex objects and you have a very complex query that you're not able to define from the JPQL as well. So Spring Data JPA also gives a support for the native queries as well. So you have a native SQL query that you can define using the @query, and you can define that this is a native query and you want the data based on that. So that also we can define. So let's go ahead and see how we can define that. Let's create one more method. Let's take the same example. Okay, let's take the same get student by email address example, but instead of JPQL query, I'll pass the native SQL query. So I just need student from here, this particular method, but I'll just define this is a native one. Okay, and I'll pass the string email ID over here, and at the red query I'll define, okay, and the value of the query. What is the query that I'll be defining over here? And then I'll define that this is the native query. Cool, right? Let me define the query now. So the query should be select star from tbl underscore student. Okay, if you go to the database, let's copy paste this query, okay, directly. I don't want this one, schema name. I'll define s, where s email underscore address equals to $1. Here you can see that with the @ query notation, we provided the value over here, and that value is select star from tbl student, where s.email address equals to $1. That is the first parameter, and we have also defined that this particular @ query, whatever the value that we are passing, that is a native query. So that is a native SQL query. Now let's go ahead and test it out. So let me just copy paste this. I'll go to the test and create one more method, public void print this. I'll annotate with the test over here, and I'll say student equals to student repository dot get student by email address native, okay, and I'll pass the email ID over here. Let's print this and let's run this. And here you can see that we are getting the data over here, and the query is executed, whatever the query that we have defined over here. Okay, so the new query is not generated based on the method name that we are giving or based on the JPQL query that we are passing over here. This is the same query that we have defined, and the same query is directly executed based on the native query equals to true flag we have defined, and we are getting the data as well. So whenever you have a very complex queries to work with, you can go ahead with this particular implementation to work with the complex queries as well. Pretty neat, right? Okay, so I'll just define this is a native query. Now suppose if you have multiple parameters that you're passing over here, passing with $1, $2 is not always the better approach. So what you can do is you can go with the named parameter values. Okay, so you'll be defining a particular naming parameter, that particular name parameter that you will be defining in your input parameters as well. So let's go ahead and see how we can do that as well. So let me go ahead and create the same thing over here. Okay, I'll just copy paste the same thing. Instead of native, I'll define native named param. So I'm defining the named parameter over here, and instead of $1 over here, I'll define colon email ID. So this is much more readable, right? And here I need to define that @ parameter. That parameter is email ID. So here you can see that I'll just define native named param. So it's more understandable for you when I'm sharing the code with you. Okay, so this particular query that I have defined over here, that query equals to whatever the query I have defined, and I have passed the named parameter values, and this is the particular method I have defined, and inside this particular input parameter I have defined that this particular input parameter defines the colon email ID parameter over here. And if you have multiple, you can add the multiple values over here, and you can pass @ param for all those particular multiple values that you have. Now let's go ahead and run this as well. Okay, I know this will be a little bit boring for you guys, but I'm trying my best to make it more understandable for you. Okay, so let me copy paste all these details. Okay, and the method is native named query named param. Okay, so here you can see that this is the named parameter method that I'm calling. Let's run this out, and you can see that we are getting the record. This is the same way. Cool, right? Now the next one is really awesome. Currently you see that whatever the methods that we have defined over here, all those particular methods are to fetch the data. All these particular, you can see all the native queries, all the JPQL queries, everything that we have defined are all fetching the data. What if you want to update the data or delete the data? Okay, that also should be possible. So that is possible using the modifying annotation. So let's see that as well. So let me go to the student repository. Okay, and currently you saw that whatever the queries and everything that we have defined, everything is fetching data. Now let's create one of the method that will update the records. Now the method that I'm defining over here is to update the first name of a student based on the email ID that we have. So I'll just define integer update student name by email ID. Okay, this is the name of the method, and here I'll be passing string first name that I want to update and string email ID, for which particular email ID I want to update the first name. Now as always, we can define using the query annotation. This will have the value, what is the query, and I'll also define this is the native query as well. So the query would be update table name, that is tbl underscore student, set first underscore name equals to question mark 1, where email underscore address equals to question mark 2. So this is the simple update query that I have defined over here. Now to make this method to modify the values in our database, we need to annotate with @modifying. Now as this is a modifying query, as it is modifying the data, there has to be a transaction for it. Okay, so all the particular methods that we want to make it transactionable, so a transaction is created, some of the operation is been performed on it, and that particular transaction is been committed back to the database. That all the things we can do using transactional annotation. With one simple annotation, a transaction will be created. All the operations like insert, update, delete, whatever that we want to do, we can do all those things, and at the end, after that particular operation is been performed, when that particular method has been completed, that particular transaction will be committed to the database. Ideally, all these particular transaction we will be adding at the service layer when we create a service layer, and we can call the multiple repository layers from that service level to make it entire flow as a transactional. Suppose if you want to insert 3 records inside a 3 different table, you will annotate your service layers method with transactional. You will call the 3 methods of the repository layer, and once everything is completed successfully, then only at the end your transaction will be committed. Otherwise your transaction will be rolled back if there is any error in it. So that's how ideally the transaction will be implemented. But for now we are adding in the repository layer because we are more focused on the JPA for now. This is the transactional annotation that we are using over here that you can use at your service layer wherever you want to create a transaction. You can create a transaction as a method level and a class level as well. Now let's go ahead and test this particular thing. Okay, so what we'll be doing over here is we will be giving the first name and email ID over here to update the record. So let's go to the test class over here. Let's create one test. I'll copy paste this particular thing, public void I'll annotate this particular method with other test over here, and I need to call student repository dot update student name by email ID. And we need to pass first name and email ID. Suppose I want to update this particular record, that is shabir@gmail.com. So I'll just pass this information that for this email ID I want to update the record, and my first name should be, suppose I'll just say Shabir Dawoodi. Okay, just for the sake of simplicity I'm just adding this detail over here. Okay, now let's run this, and here you can see that update query was executed. Update this table, set first name equals to whatever the value, where email address equals to this particular email address that we have passed over here. And if we execute the query again, here you can see that my first name has been updated with the new values that we have defined over here. So we just saw that we have defined two annotations, that is @transactional to define a particular transaction for this particular method, and also @modifying annotation whenever you want to execute any queries that has been modifying the record in your database. The same will be applicable when you want to delete the records as well. So here you can see that we saw a lot of things about the repository, different repository methods, how to create a different methods, how to use the queries, how to use the native queries, and how to modify the queries, how to modify the records using the modifying annotations as well. Now we will see the different relationships available in the JPA. Now firstly, we will check one-to-one relationship in JPA. Now with this particular class diagram, you can see that we have two classes, that is a course class and a course material. And for this particular two classes, that is course and course material, there is a one-to-one relationship, because for one course there will be one course material, and for a course material will be only available for a particular course over here. So this is a one-to-one relationship, and for this particular thing, how a table will be created is like, you can see that for a course that contains a course ID, a course title, and a course credit, and the other course material is having a course material ID and the URL to it. So what will happen is, either of the table will contain a foreign key of the other particular table that we have. So a course ID is a primary key for the course table, so that particular course ID will be behaving as a foreign key for a course material table over here. So let's create these two classes, course and course material over here, and let's see how we can define one-to-one relationship. So let me go to the IntelliJ IDEA, and with this particular entity package, let's create course entity and a course material entity over here. So I'll just create a new class that says course over here, and I'll create one more entity that says course material over here. Okay, let's go to the course and let's define this as an entity, and we'll annotate with @data for Lombok, @allargs constructor, @noargs constructor, and @builder. Just the standard stuffs. Okay, let's do the same for the course material as well. @entity, @data, @allargs constructor, @noargs constructor, @builder pattern. Now let's create the attributes over here. So here I'll define private long course ID, private string course title, private integer credit over here. So these things are defined over here. Now let's define the course material ID and URL in our course material class. So let's go to the course material. I'll say private long course material ID, private string URL for the course. Okay, just a simple thing over here. Now this course material ID and the course ID in the course class both have the primary key, so we need to define the primary key for it, and we need to define the sequence generator and the generated values, how the values are generated. So let's do that. I'll annotate with @ID over here, and for this course ID, let's define sequence generator, and the name of the sequence generator I'll define, sequence name we will define, and the allocation size I'll define over here. So I'll just say course sequence, and the sequence name is course sequence. Okay, and how the values are generated. So @generated value, strategy would be generation type.sequence, and the generator would be course sequence over here. Let's define the same thing in course material. @ID, @sequence generator. Well, I'll define the name of the sequence generator and the name of the sequence as well, and I'll also define the allocation size, that is 1, and I define course material sequence. Okay, and generated value, I'll define this strategy equals to generation type dot sequence and generator equals to course material sequence over here. Now we need to define the mapping over here. Now between course and course material, the mapping that we can define is course material will consist of a course. Okay, course material cannot exist itself. It has to have a course so that we can add the course material to it. So for that, in the course material, we'll define private course over here. Okay, and for this particular thing, we'll define one-to-one mapping. Now this we've defined that this is a one-to-one mapping. Now we need to define for which particular column that a foreign key will be applied. Okay, so for that we need to define join column over here. For which particular column that we can join these two particular tables. So here I can define name of the column and I can define the reference column name. So which particular column it is referencing to. So inside this course, it is referencing to course ID over here. And what is the name of the column? That would be course ID. Okay, simple. We just define what will be the join column. In the referenced column name, we define which particular column this is referencing to. So in this course, it is referencing to this course ID, this particular attribute. And what would be the name of that column? We have defined that the name of the column should be course ID. So in this particular course material table that we are going to create, this particular course material table will have an extra column that will be course underscore ID. So that will refer which particular course this belongs to. Now all the standard stuff that we saw earlier, all the things applied here as well, that we can define at the red column, we can define at the red table, we can define the unique keys, we can define different constraints over here. Everything we can do over here also, but we have a limited time, so I'm considering that you can do all those things by yourself by referencing to what we did in the student class. Everything you can do here as well. So let's go ahead and let's start our application and let's see what are the different tables is created. So I'll just run the application, and once the application is successfully started, you can see that there are the different queries created. You can see that table course is created. Okay, course material sequence is created, course material sequence value has been inserted, course material table is created, and the course table has been altered, adding the foreign key over here. And if you go to the database over here, and if you refresh the database, here you can see that course table has been created, course material table has been created, and the two sequence tables are created. And if you open the tables over here, let me open the course table, and here you can see that in the course there are three columns over here, that is course ID, the name of the title of the course, and the credit available. And if you go to the course material, you can see that course material ID, the URL of the course material, and the course ID which this particular course material belongs to. So this way we have added the primary key and foreign key relationship between the two tables. So here for every course there will be one course material, that is a one-to-one relationship. Now let's create the repositories for our course and course material over here. Okay, so let me go to the repository and let's create the interface over here, and I'll say this is course repository. Okay, and this extends JPA repository, and this is of course, and long is the ID over here, and I'll annotate with @repository. And I'll create one more, that is course material repository, and I'll extends JPA repository with the course material and long, and this is @repository. Okay, we just created two repositories, course repository and course material repository. Now what we will do is we will test this particular thing out. So we'll create the test class for this course material repository over here, and we will try to save a course material with the one course over here. Okay, so let's generate the test class over here. This is a particular test class that we generated. Let's annotate with Spring Boot test over here. And for this particular course material repository, what we need is private course material repository, and I will auto wire it. So this is the particular repository's object that we want to create the different methods. So let's create one method to save the course material with the course. So I'll just say public void save course material. Okay, and I'll annotate this with @test over here. Now let's create the course material equals to course material dot builder dot URL. So what's the URL? I'll just say www.google.com.course, and here we need to pass the course object over here dot build. So let's define the course object as well. Course equals to course.builder dot course title equals to, let's say, data structures and algorithm dot credit. I'll say there's a 6 credit for this particular course dot build, and I will pass this course to my course over here. Now let's save this course material. So I'll just say repository dot save course over here. Sorry, course material over here. Okay, simple thing, right? We created the object of a course material over here, and this course material has to have a course for which particular course that we want to save the data. So we defined that as well over here, and we are trying to save that particular course material over here. So now let's run this and let's see what is happening over here. Okay, so let me run this. Blah blah blah, and it failed. Okay, let's see why it failed over here. And here you can see that the error is invalid data access API usage exception, transient property value exception. Okay, object references and unsaved transient instance. Okay, object references and unsaved transient instance over here. For what? Course over here. Okay, what we are doing over here is we are trying to save the course material without saving the course over here, because what is happening over here is we are trying to save the course material, and for this particular course material we have to have a course that is already saved in the database, but it's not. I have not created any of the course over here. What we are trying to do is when we save the course material and we also pass the course, and if that course is not available, we need to create that course as well. To make this thing happen, currently you can see that it's not happening, but to make this thing happen, cascading comes into picture. Once we implement the cascading means what? Cascading means to pass the properties or to pass the permissions to your child elements from the parent to child. Currently you can see that I want to save the course material and I want to persist it, and we have a course that is not persisted, so we will cascade the information. We have different cascading types, so we are passing that information. Okay, I'm trying to persist this particular course object is not available. Okay, no problem, try to persist that as well. So there are different cascading types available. Okay, that's an enum available, so we can define that, and accordingly what we define, this particular operation will happen. So let's go and define that. So we'll go to the course material, and in one-to-one mapping over here we'll define cascade equals to cascade type dot. You can see that there are different options available, that is cascade type dot all, detach, merge, persist, refresh, remove, whatever. So whatever you define, the operation will happen accordingly. For the simplicity, I'll define cascade type dot all. So whatever the operations are there, everything will happen over here. Currently you see that in the course and course material there is no data, there is no course material, and there is no course as well. If you go back to our IntelliJ idea, if you go to the test class, earlier it failed. Now let's run it again. And now here you can see that this is successful, and if you go down you can see that how many queries happened. You can see that first the course was inserted, okay, after that course material was inserted over here. And if you go to the database and if we run the query, you can see that the course is created with course ID 1, credit 6, title is DSA. And if you come to the course material, this course ID should be used over here. You can see that course ID 1, the URL is this, and the course material ID is 2. So with this particular cascading type information, we were able to do this. Now, once we go back to the course material over here, okay, there is a different thing available that is called fetch type. How we want to fetch the data. There are two types of option available, that is eager fetching and lazy fetching. So what's the difference between that? The difference is, so if you are having a relationship between the two tables, so once you call the data of a parent, so suppose currently when you call the data of a course material, do you need to fetch the course also with that, or you just need the course material only? So based on the application that you have, you can define the fetch type. So when you define the fetch type as eager, it will bring the course data as well when you try to bring the course material. But when you define fetch type as lazy, it will not bring the data of a course until and unless you specifically ask to bring the course. Okay, so in this particular one-to-one relationship, there is a fetch option available. So with this particular fetch, you can define either is a fetch type eager or fetch type lazy. So I'll just define fetch type lazy over here. Now let's go back to the test and let's add the method to print the course materials. So I'll just say public void print all courses. I'll annotate with the test over here, and I'll say list of courses. Sorry, I'll say list of course materials. Okay, course materials. And I'll say course materials over here equals to repository dot find all. Okay, and I'll just print it. Okay, simple method. So let's run this. Okay, you can see that it is throwing the error that could not initialize the proxy for the course. So what I'll do over here is, there's a toString method that is calling the course over here. So I will remove it for now. So I'll just define @toString and I'll exclude course over here. Let's run this again. Now as we have defined the fetch type as lazy, you can see that we are getting only course material over here. We have excluded the course as well from the toString method, so it won't call that particular get course method over here. So ideally, as per the requirement that you have, you can define that what should be your fetch type. Either it would be eager or lazy over here. Now you can see that we define the find all method for the course material over here. Now let's go to the course and let's get the courses available over here. So let me go to the course repository over here and let's create the test class for this as well. I'll add the Spring Boot test over here, and I need to add the course repository as well. So I'll just add private course repository and I'll auto wire it, and I'll have a method public void print courses, and I'll annotate with other test over here. I'll have list of courses equals to course repository dot find all. Okay, and I'm printing the courses available. So let's run this. Now here you can see that you are getting the list of courses available. Okay, what is the course available? Now ideally when you're getting the courses, you want the course material as well. So ideally when you are getting the courses, you want the course material as well, because then only you'll be identify what's the material for that particular course, right? There is no point of getting to details separately. But how to get the course material from this particular course repository? Because you have created the course material repository Okay, and when you are working with the course material object, you are getting the course material with the courses as well. But when you are working with the courses, you are not getting the course material. Why? Because you have defined only unidirectional one-to-one mapping over here. We don't have any course material references in our course. So you can see that in the course material you have a reference to courses, but if you go to the courses, you don't have any reference to course material because you have only defined unidirectional one-to-one mapping. Now let's see how we can define the bidirectional one-to-one mapping over here. So for this particular courses, you need the reference to the course material, but you already defined one-to-one mapping over here. So what we can do is we can come to our courses entity over here, and here we can define private course material over here, and here you can define this is one-to-one mapping over here. But here you cannot define the joining columns, right? Because you already defined in the course material. So here you need to say this is mapped by some other class, right? So you can tell this is mapped by what? This is mapped by this particular course in this course material class over here. So what you are defining over here is you need a reference of course material in your courses to define one-to-one bidirectional mapping. But that one-to-one mapping to join a column for a foreign key is already defined in the course material. So you're telling that this particular one-to-one mapping is already defined by the courses attribute in course material class over here. So in this course material class, there is a courses attribute that has already defined one-to-one mapping over here. Cool, right? Now let's test it again. Now if you go back to the test over here, and already earlier you can see that we only got the course over here. Now if we run it again, we should get the course with course material. So here you can see that the test case is passed over here, and if we go down over here, you can see that we got the course, also we got the course material as well, right? So we defined bidirectional one-to-one mapping. So we define the reference of course material in the courses as well. So this is how you define unidirectional or bidirectional relationships in any of the relationship types. Either it is one-to-one, one-to-many, many-to-one, or many-to-many relationship. So I just showed you in one-to-one. The same concept and the same implementation goes in all the other three as well. Now let's see one-to-many relationship. Now if you come to this particular architecture that we have defined over here, we just saw course and course material that is having one-to-one relationship. Now if you come over here, teacher and courses over here, that is having one-to-many relationship. One teacher can teach multiple courses over here. So that is a one-to-many relationships. And the reverse would be many courses can be taught by one teacher. So that would be many-to-one relationship. So let's go ahead and first see one-to-many relationship, and then we will see many-to-one relationship. So let me go back to the IntelliJ idea. We already have course and course material classes created. Let's go ahead and create the teacher class as well. So teacher has teacher ID, first name, last name. So let's go ahead and create that. So I'll go to the entity and let's create the Java class says teacher, and I'll annotate with @entity over here, @data over here, with all args constructor, with no args constructor, and build a pattern. Now this teacher has private long teacher ID, private string, first name, private string, last name over here. These are the three fields available for a particular teacher class. You can add multiple, but let's add it only three for the simplicity over here. This particular teacher ID would be our primary key. Okay, and we need to define the sequence generator and generated value as well for here. So I'll just define sequence generator. The name of the sequence generator I need to define, the name of the sequence I need to define, and also allocation size I'll define as 1. I'll just say teacher underscore sequence over here. The same value I'll define over here in the sequence name. Okay, the spelling is wrong, I'll just correct it out. Okay, and I'll define the generated value as well. @generated value. I'll define the strategy equals to generation type dot sequence, and generator I'll define as teacher sequence over here. This is a simple thing that we have defined over here. Now what we can do is this particular teacher and course have a one-to-many relationship. One teacher can teach multiple courses. So a one teacher can have a list of courses inside a particular class. So I can define this way, right? If I go to this particular teacher class, I can define one attribute as private list of courses. Okay, that this particular teacher have a list of courses which a particular teacher can teach. So I can define this particular is a one-to-many relationship. As we defined the cascade type in the course and course material, here also we'll define the cascade type. I'll just simply say cascade type dot all for now, simplicity. Now for this one-to-many relationship, there will be two tables. One will be teacher, one will be course. For every teacher, which particular course that particular teacher is teaching, that particular relationship will be having. So you can consider that course table will be having a extra key, foreign key, that is a teacher ID. That particular column will define this course is taught by which particular teacher. So we need to define joining column over here. So we can define joining column, name of the joining column, and reference column name. So what will be the reference column? Reference column will be this particular teacher ID. Okay, and what would be the name of the column? I can say teacher underscore ID, whatever you want to name the column. So this is a simple unidirectional one-to-many mapping over here. Okay, and we have defined cascade type as all over here. I hope this is very clear. This is a very simple thing. We just define one-to-many relationship between two particular classes, that is teacher and course. Teacher can have a list of course that a particular teacher can teach. Okay, so we just define that way over here. Now let's start the application. Okay, and a particular teacher table will be created. Yeah, you can see that my application is started, and you can see that teacher table was created. Okay, and the course table was altered, and a new foreign key was added to that particular course table over here. Simple, right? And if I go back to this particular database, and if I refresh my database, you can see that now course table was having only 3. Now if I run it again, you can see that new teacher ID has been added over here. And if you see over here, there will be new teacher table also created. What's the teacher available? Now let's go ahead and create the teacher repository as well. Teacher repository as the interface, and that extends JPA repository, that is of type teacher and long, and I'll annotate with @repository. Now for all these particular things, you can define all the methods, different methods that we already saw in the prior part of this particular video, right? So for this particular teacher repository, let's create the test class, and I'll annotate with @Springboot test, and I need private teacher repository, and I'll auto wire it. Let's create the method to save a teacher, okay, with the course. So I'll just say public void save teacher, and I'll annotate with test over here. I'll say teacher equals to teacher dot builder dot build dot first name equals to, suppose Kutab is a teacher, dot last name say Khan, and dot what courses this particular teacher is teaching. Now this particular course is, it is taking the list of courses. Okay, so let me just create one of the course, or you can create one method to add the course to that particular courses list as well. Okay, whatever is feasible you can use that way. Ideally it should be you create one method that adds the course to that particular list of course. For the simplicity, I'll just do a cheating over here. I'll just create a course equals to course dot builder dot build. I'll just say course title equals to, I'll just say DBA dot credit is 5 and build, and I'll just use this course as list dot of courses. Simple. Now let's add the teacher repository dot save teacher. Simple, right? I just created the teacher object over here. This teacher is having a list of courses. I just added one course. Let me add multiple. Okay, I'll just say course DBA and I'll add one more course. I'll just say Java, it is teaching Java, credit is 6, course DBA, course Java. 2 courses. This particular teacher is teaching 2 courses, so I just defined this way. Now let's run this. So here you can see that it is successful. You can see that one teacher was inserted. After that 2 courses were inserted. Okay, and those particular 2 courses were updated by the teacher ID that we have inserted. So let's go and see this. You can see that one teacher was created, that is Kutub Khan. Teacher ID is 1. And if you go to the courses over here, okay, and if I run this, you can see that this particular 2 course DBA and Java is created and it is taught by teacher ID 1. Teacher is 1 over here. And if you see this particular 2 courses 2 and 3, for this particular 2 courses there are no course materials over here. Okay, so now this is something that we can take care of, right? Because ideally what we can do is, when you define a course, you should save a course material with it, right? Without a course material, you should not be allowed to save a particular course over here. But currently you can see that we were allowed, right? We were able to save this particular thing. So how to do that? So that is optionality. Optionality means it defines that whatever the relationship is, that it's an optional relationship or a mandatory relationship. So it defines. Currently you can see that by default everything is optional. Okay, there is nothing that is telling us that this is mandatory. Currently when we save the course without adding the course material as well, we were able to save it. So let's see that. So if you go back to our course and course material over here, so if you go back to the course and course material, here with this particular one-to-one relationship, I can define optional equals to false. By default it's always true. So now I have defined over here that whenever you are trying to save a course material is required. It's not optional over here. So let's go back to the course material repository test and let's try to save the course over here. And we already have one save course material. Let's use the same thing over here. Okay, what I'll do, I will not define the course over here. Okay, and I'll just change the material as, let's say, daily code buffer. Okay, and let me save this. Let me try to save this. And here you can see that we got the error over here. And here you can see that what it is asking here is data integrity violation exception, non-null property reference and null or transient value over here for this particular course. So that means this is forcing us to add the course over here. Okay, so now if let me just change the name over here. Okay, I'll just say .NET. Okay, now if I add this particular course back, okay, for this particular course material, then only it will run now. See, here you can see that it is successful, right? You can see it was updated. Now if I go back to the MySQL and go to the course, you can see that new course was added, .NET. Okay, and if you go to the course material, course material was added for it. So this way you can define the optionality for your entities that you have created, which of the particulars entities or which of the particular objects and classes are optional or not. Now let's go back to the one-to-many relationship. Here for this particular teacher repository, teacher class, we have defined that teacher contains a list of courses available. That's a one-to-many relationship. Now what will be many-to-one relationship? Many-to-one relationship would be there are many courses available and those particular courses are being taught by any one of a teacher. So rather than defining this way, like this particular class, this particular teacher have a list of course, we can define a particular teacher who is teaching a particular course that we define. That is more readable, more understandable, and that's a guidance provided by a specification of JPA that you should always go for many-to-one relationship whenever possible. So what I'll do, I'll just comment it out for now over here. Okay, I'll just keep this in the code as well so you can refer it out. So what I will do, rather than defining this way, I will go to the course over here, and for this particular course I will define that this particular course is taught by whom. So I'll just say private teacher, and this is many-to-one relationship. Okay, we just reverse it, one to many, this is many-to-one. Now here also we have to define the join columns over here. We can define the name of the join column and also define the reference column name over here. The reference column name would be inside the teacher, this will be teacher ID. Okay, that would be reference, and we'll define with same teacher ID. Now with this particular change, there won't be any change in your database. Everything will remain the same. This is how you represent all your tables in your objects. That's a representation change over here, but the structure will remain the same. And this is still many-to-one unidirectional relationship. Now when we are trying to, now here as well, in many-to-one relationship, whatever you define in over here, you can define cascade type all over here. So whenever you are saving a new course with a new teacher and a new course material, all the things will be saved or all the things will be deleted, whatever is preferable. Okay, now let's create a course with all the particular values. Okay, so I'll go to the course repository test over here. I'll say public void save course with teacher object. Okay, I'll annotate with @test over here, and what I'll define over here is course object course equals to course dot builder dot, what's the title of the course? I will just say Python dot credit is 6, and dot, you can define the course material as well. Let's define the teacher, and for this particular teacher, what I can do, I can create the teacher object teacher equals to teacher dot builder dot build dot first name, I'll just say Priyanka dot last name Singh dot build. Okay, this is the teacher. Now this particular teacher I'll pass to this particular course, that this particular Python course is taught by Priyanka Singh, and now I can directly say course repository dot save this course over here. Here you can see that I'm just doing the save over here. It applies to update, delete, get all data, get a particular data, for everything this applies. Okay, I'm just giving you a very simple implementation over here so you can understand. Now let's run this. So what should happen over here is a new teacher should be created, a new course should be created, and for that a foreign key of a teacher should be assigned to a course. So let's run this. And here you can see that there is an error over here. That's fine, I'll just comment it out over here for now. Okay, because we just removed the reference of the courses over here. So let's do this, save courses with teacher again. Here you can see that the course is created and a teacher is created. Okay, so let's go back. Let's go to the teacher table, and here you can see that new teacher is created, that is Priyanka Singh with teacher ID 2. And if you go to the courses and if you run the query, you can see that new course Python is created and taught by teacher ID 2 over here. Simple thing, one-to-many and many-to-one relationship. Now let's see how to implement paging and sorting using JPA repositories. Now, as you are already aware that for every repositories we have implemented the JPA repository, and this JPA repository again extends the paging and sorting repository. If you go to this paging and sorting repository, you can see that either you can implement the find all method or find all method based on the sorting or based on the pagination. You can implement the pagination and it will return the page object with the particular data type that you are passing, particular type of object, and that will take the pageable as the input parameter, where you will define the different page number and how many records that you want for that particular page. And for the sorting as well, that you can define what kind of sorting that you need to implement for fetching the data. So let's go ahead and see how to use this particular default methods and how we can implement the custom method as well. So let me just close this, and for this particular course repository, let's go to the test over here and let's call this particular method. Okay, so let me just create a new method over here. Okay, I'll just say public void find all pagination, and I'll just do @test over here, and here I'll define the pageable objects, and I just say pageable first page with three records equals to page request dot off method. Here you can see that this particular method takes the page number, the size of the page, and the sorting for that particular page. So I'll just define the 0th page, that is the first page, and I want 3 records over here. So I'll just remove this. I'll just remove this as well. Let me create one more object of pageable. I'll say second page with 2 records equals to page request dot off. I'll say second page, that is first, and I want 2 records. I just created this particular object over here. Now I need the list of courses available for this. So I'll just say list of courses available equals to course repository dot find all, and inside this find all I'll just pass first page with 3 records and dot get content. So this is a simple method that I am using find all, where I'm passing the pageable object that you saw over here. Okay, you can see that it is taking the pageable object over here as an input parameter from the paging and sorting repository. Okay, so I'm just using that particular inbuilt method over here, where I will just define the 2 pageable, first page with 3 records, second page with 2 records over here. First page, that is 0th page, 3 records that I have defined 3 over here, and this particular object will return the page of courses. From that particular page of courses, I have used .get content method to get all the contents of that particular page. Now there are more details also available. We can get the different things such as total pages and total elements as well. So let's do that as well. What I'll do, I can define long total elements equals to dot. Here you can see that there are a lot of different methods available. Dot get total elements, you can convert to stream as well. Okay, you can get the contents, you can get the number of elements, you can get the total pages. Okay, all those things you can do over here. So let me just get the total elements over here for now, then I can have total pages as well. Okay, I can say long total pages equals to course repository dot find all first page with 3 records dot get total pages. Okay, and I can define this particular total pages as well. And if you go to the database, currently I have 5 records available. Now let's run this. You can see that there are a lot of queries available. Okay, these all the queries were executed, and you can see that there were a total of 2 pages and the total elements are 5. Why there are 2 pages? Because I've defined that my page should be of 3 records. Every page should be of 3 records. Okay, so that's why I divided into 2 pages, and I want the first page. So first page should contain 3 records. So here you can see that first course, second course, and this is the last third course available. So 3 courses are defined over here. Now if I pass the second value, second page with 2 records everywhere, and if I run it again, I should be getting 3 pages because each and every page should be of 2 records. Okay, here you can see that I'm getting total pages as 3. My total elements are 5, and as I need to have the second page, I will be getting the 2 records of the second page over here. Okay, so this way you can implement the by default find all function using this particular pagination as well. Okay, now let's implement pagination with sorting. I'll just create one more method, public void find all with sorting. Also, this is a test over here. Suppose I want to sort the data based on the title. Okay, so what I can do is I can use pageable sort by title over here, page request dot off. I can say 0th page with 2 records, and sort dot by I can say title. Okay, simple page request, just like over here whatever defined over here, but here I just added the sorting as well. I can also do pageable sort by credit descending order as well. I can do page request dot off first page with 2 elements dot sort dot by credit dot descending. So this will sort the records by credit in the descending order. I can also define pageable sort by title and credit descending order. Okay, for this I can do page request dot off, can do first page with 2 records where I can define sort dot by title and descending order dot end, again do sort by credit. Simple, right? And now I can pass everything over here. I can do list of courses over here equals to course repository dot find all, and inside this find all I can pass anything. I'll just say pass sort by title over here dot get content, and let's print it out. Okay, and we can run this. So here I just gave you the different ideas like how we can use this particular different sorting, multiple sorting, descending order, ascending order. Okay, and we can pass that particular page request to our find all method, and we can get the data over here. So let's run this, and here you can see that we are getting the data over here. Now we can create the custom method as well for the sorting. Okay, so what we can do over here, we can go to the course repository. Okay, let's create the method over here. What we can do, list of courses over here. Okay, and for this particular list of courses, what I need, find by title, find by title containing, find by title containing over here, and here we need to pass the string title over here and page request. So this will convert all your data to the list, but here you need a page over here. Okay, that you should be getting the page. So whatever the page request that you pass over here, you will be getting the data as a page object over here. So let's check this as well. So we will just call this. Okay, we'll create a new method, public void print find by title containing, and I'll just use test over here. Here I'll just say pageable. Again, first page 10 records. Okay, equals to page request dot off first page and 10 records over here. Now what I need a list of students, list of courses equals to course repository dot find by title containing, I'll say containing D, and first page 10 records over here, and here I'll say dot get content. Okay, I did one mistake over here. This should be pageable. Okay, right now let's go back over here, and here you can see that the error is resolved. Now let's print it out. Okay, I'm printing the list of courses available with the first 10 records of the first page, and we are just getting the title who's containing capital D. So if I go over here, how many capital D, how many records you should get is DSA and DBA over here. So let's go back and run this over here. And here you can see that we got the records. Okay, we got DSA and we got DBA, nothing else. Okay, so my method is working perfectly fine. So this way you can go ahead and implement paging and sorting using JPA repositories. Now let's implement many-to-many relationship. So with this particular image, we implemented course and course material, that is one-to-one relationship, teacher and course, that is many-to-one and one-to-many relationship. The last one is student and course. The student and course have many-to-many relationship. Many student can opt for many courses available over here. So we already have a student class and a course class over here. Now we have to implement the many-to-many relationship. How many-to-many relationship works is, we already have a student class, we already have a course class over here. Okay, two classes are already created. Now when you implement a many-to-many relationship, there has to be a third new table added to it that represents the mapping between the two tables, that is a student and course. You have a student, you have a course, and there will be a third table that represents this particular student ID to this particular course ID. So multiple student can have multiple course ID, so that particular table will hold the relationship between the two entities that we have. Okay, so there is a third table, new table will be introduced for many-to-many relationship. In the earlier, in one-to-one and one-to-many or many-to-one relationship, there are only two tables associated always and a foreign key was assigned. But here, third table will be introduced over here. So let's go ahead and implement that. We'll go to the IntelliJ IDEA and we go to the courses over here. This particular course is, here we need to add the many-to-many relationship. We already added one-to-one, many-to-one relationship. Here we need to add the other relationship, many-to-many, for the students that we have. As a particular course can be opted by multiple students, so we need to have a list of students available over here, right? So I'll just define private list of students available over here. Now for this particular, we need to define many-to-many mapping over here. Now as for this particular many-to-many relationship, as I told that there has to be a new table created, we need to use the join table annotation over here. You can see earlier we used to just use join column annotation. Here we will use join table. So I'll just use join table annotation over here. And in this particular join table annotation, we need to define what will be the join table, what will be the new table, and which two particular column that we are going to refer over here. So let's add those information. So here I'll just define what will be the name of a table. So I'll just say student course mapping over here. And here I'll define what will the join column equals to @join column over here. And for this I need to define what will be the name and what would be the reference column name over here. So what I need to refer to what for this particular student, I need to refer to the course ID. Okay. So whatever the course ID is available over here, that would be the reference column. And what would be the name of the column that I want to define? That is course_ID. Okay. This would be your database, what you want to define, and this would be your class property that you have already defined over here. Now this is the joining column that you have defined for your student, that is your student will be having the courses. Now you need to define the inverse join column as well, that for your courses what should be for the student. So I'll just define inverse join column equals to @join column. What would be the name? What would be the reference column name? And this would be for your students. So if you go to the students, this student ID would be your reference column name over here. And your table name, your column name should be student ID. Okay, so what we defined over here, that for this particular course and for this particular students that we have, we are creating a new table that is called student_course_map, that will have two columns, that is course ID and the other is student ID. This course ID will refer to the course ID of this particular class, and inverse column join, okay, that is whatever I need to define for this student over here. Okay, so whatever you defined over here, the list available for many-to-many mapping, that would be for your inverse join columns. Okay, so I need my column name as a student_ID, and it refers to the student ID of this particular class that I have defined over here. It's really simple to understand, just it looks complicated. Okay, it's really simple. You just define the new table that contains the mapping between the two already created table for many-to-many mapping, that is a student and a course you have. And as multiple students can opt for multiple courses, you need to normalize those tables to remove the redundancy, and for that you created a new table. That new table contains the mapping between your course and a student. Simple. So this is the definition that we have provided for many-to-many mapping. That's it. As is a list of students, I already told you earlier as well, when you are working with a list, you can create one more method to add the letter to that particular list. So let me just create a method. I'll just say public add students. Okay, this will take student object, and if students equal to null, students equals to new array list. Okay, else directly I can say students.add student. Now let's go ahead and test this particular thing out. Okay, let me start the particular application. Okay, and here you can see that if you see create table, student course map is created, where we have two different IDs, that is a course ID and a student ID, two columns available, and it refers to the two different foreign keys. That is a student course map refers to the foreign key of a student ID and a course ID over here. And if you go to the database, if you refresh it over here, you can see that student course map is created over here. So let's try this out. So in the course repository test over here, course repository test over here, let's implement one method. Okay, public save. What we'll try to do is we will try to save a course with a student available. Okay, save course with student and teacher, public void @test course equals to course.builder.build dot course title. What's the course title? I'll just say AI dot credit. What would be the credit? I'll just say 12. Okay. Dot, I need to add the teacher as well. So suppose I already have a teacher, or let's create a new teacher as well. So I'll just say teacher equals to teacher.builder.build teacher first name Lizzie dot last name Morgan. This is the teacher. Now let's add the students as well. Okay, here I can add the students. Okay, so what I can do, let's create a student as well. Student equals to student dot builder.build dot first name Abhishek, last name Singh dot email abhishek@gmail.com. Do I need to add guardian? If I don't add, that's fine. I don't want to add it now. This is the student. I can add multiple student as well, but let's add one student only. Okay, so I just added the student as well. So I just created my entire course object. Let's do course repository dot save course as well. So we just created teacher, student, and we just added all the details in our course as well. So let's run this out. Let's see what's happening over here. Okay, and there is an error. That's good. You can see that invalid data access API uses exception, right? Because you can see that transient object exception is there. Why? Because we added the student over here and we have not defined the cascading type. Okay, so let's go back to the course over here, and for this particular students in many-to-many mapping, we can define the cascade type as cascade type.all for now. Now let's go back and let's run this again. Yeah, you can see that it is successful. Okay, and if you come over here, you can see that there is an insert into teacher, insert into course, insert into student as well, and insert into course student map as well. Okay, so let's go and check our records as well. So we added the new course, right? So this is a new course, that is AI. Okay, this AI has been taught by who? Teacher ID 4. So if you go to the teachers, and teacher ID 4 is Lizzie Morgan, that is ID 4. Now which particular student, right? If you go to the student as well, a new student was added, that is Abhishek. Okay, now if you go to the student course map over here, there will be mapping which particular course is been added by which particular student is taking that particular course. Student ID 3, that is Abhishek, is taking the course 7 over here. Okay, so there will be a multiple mappings this way. This will be a many-to-many mapping handled by the third table, that is a joining table over here. So this is a many-to-many relationship in JPA. So here you can see that we have covered a lot of things over here. We covered all the relationships like one-to-one, one-to-many, many-to-one, and many-to-many relationships. We did paging and sorting as well, how to get the data in the pagination form and in the sorted form as well. We also implemented the native queries and JPL queries as well. And we also implemented the named parameters. We also went ahead and saw how to do transactional and how to do the modifiable queries as well using the JPA repositories. So there is a lot of things that we have covered, and if you have any questions related to any of the topic that we have covered, then do let me know in the comment section below. I will try to resolve your issues as soon as possible. Now as you have gone through everything over here, you will be able to create all the particular different operations and handle everything using this particular JPA itself. Now there is an advanced thing also available using the default entity manager as well, that you can go through the documentation and you can create the entity manager object, and you can also do the custom method implementation as well. Here you can see that we did everything using the interface, but you want to do the implementation, custom implementation for all those particular methods, that also you can go ahead and do that. But ideally, if you're using JPA, this is my preferred choice as well, because this will reduce a lot of coding efforts, and a standard implementation is given by JPA. So all the particular implementation what has been done, that's a standard format, it's well implemented, and we just have to use those particular methods. So we'll be getting a really good performance as well over here. Now it takes a lot of time to create these videos for you guys, so a like and subscribe will be really appreciated. So that's all in this particular video. I will see you in the next video. Till then, happy coding. Bye bye.